Good morning. My name is Sathish Kumar from Electrical and Electronics Engineering Department. I am going to teach subject DC machines and transformer. Today topic is types of DC generators. DC generators is classified into various names according to the application or according to the connection of winding, that is according to the construction of DC machine. We have armature winding and as well as the field winding. So according to these two windings, we have different types of DC generators are there. The classification we will see now. That classification is according to the excitation. We have two types of the generators are there. That is self-excited DC generator and separately excited DC generator. So, self-excited DC generator. This is again classified into three types. That is according to the winding. That is armature winding and field winding. According to that one, we have DC shunt generator, DC series generator, DC compound generator. Again, this compound generator again classified into two types, that is long shunt compound generator and short shunt compound generator. We will discuss what is meant by shunt generator, what is meant by series generator, what is meant by compound generator, what is meant by separately excited generator, what is meant by self-excited DC generator. We will discuss. So, coming to separately excited DC generator. In separately excited DC generator, again we have armature winding is there, field winding is there. This connection means we need to excite the DC machine or DC generator of armature winding as well as the field winding. We need to excite. That is the case in case of the separately excited DC generator. The field coils, whatever the field coils are there in case of the separately excited DC generator, that field coils are strengthened, means are excited, strengthened or are excited from an autonomous excited DC source. Means autonomous is nothing but separate DC source. We need to use the excite the field coils of DC generator or are strengthening of the field coils of DC generator. We need to use separately DC source or autonomous excited DC source we need to use. That type of DC generator we are calling as a separately excited DC generator. Next is self-excited DC generator. In case of the self-excited DC generator, again the field coils are strengthened from generated current within the generator. That is, the generator of first electromotive force will occur because of its outstanding magnetism within the field coils. That is, according to the residual magnetism in the DC generator, will get the initial induced EMF in the field coils. Due to that initial induced EMF of field coils, we are getting the current will be generated in the field coils. That generated current will be strengthen the field coils or excite the field coils itself only. That's why this is called as a self-excited DC generator. In case of the self-excited DC generator, the produced electromotive force will cause a fraction of current, means some current only will be there. That fraction of current will to supply in the field coils. That's why which will increase the, if the field current will be increases, therefore which will increase the field flux. If the field flux will be increases, automatically electromotive force will be generated in the field coils. So further, these type of DC generators can be satisfied into, that is, three types, that is according to that field winding connection, that is namely series type DC generator, shunt type DC generator, compound type DC generator. Now coming to series generator, both actually we have, in case of the DC generator, we have armature winding as well as the field winding is there. So according to that windings, in case of the DC series generator, the armature winding and the field winding both are connected in series. That's why that type of generator I am calling as a DC series generator. If field winding and as well as the armature winding both are connected parallel with each other, then that type of DC generator I am calling as a DC shunt generator I am calling. Next, again, the compound winding is the blend of series winding as well as the blend of shunt winding. That type of generator I am calling as a compound generator. So this is the, according to the excitation, according to the winding, we have the classified the DC generators. Now we'll discuss separately excited. This is the separately excited DC generator. In case of the separately excited DC generator, you can observe here. So this is the armature winding. So this is the armature winding. This is the field winding. Both are connected separately. So according to the separately excited DC generator, an autonomous source is connected separately to the field winding coils. That is, I am taking here DC source. This DC source is connected to the field winding to strengthening the field winding or to excite the field winding. We are using here separate source. That's why this is called as a what? Separately excited DC generator. In case of the separately excited DC generator, so this armature winding is connected to the load, then this is the armature winding. This produces the armature current I suffix A and load current IL I suffix L. So both are connected in the series. That's why what I am getting here, IA is equal to IL. IA is equal to IL I am getting. Now you can write induced EMF equation of DC generator. So what you can write now, you can see here now. This is the load voltage V. Then you can apply, I am here KCL. All of you know very well what is meant by KCL. Sum of the currents in the, sorry. So you can apply here KVL. All of you know very well what is meant by KVL. Kirchhoff voltage law. Sum of the voltage in the loop will be is equal to 0. So then according to that one, so this is the induced EMF generated in the armature winding is E, load voltage is V, and the armature voltage is I, armature current is I suffix A, and the armature resistance is RA. So then this is I am getting the IA into RA is nothing but as a armature resistance drop. That is armature resistance drop is IA into RA plus again I am getting here brushes. According to the construction of the DC machine, we have the brushes are there. That is brush current drop. That is brush current drop is there, BCD. So now you can apply here KVL, that is sum of the voltages in the loop is equal to 0. Then I am getting E is equal to V plus E is equal to V plus IA into RA plus BCD, brush contact drop. This brush contact drop is usually 1 volt per brush, 1 volt per brush, where R suffix A is equal to armature resistance. So this is the voltage equation of the separately excited DC generator. That is V is equal to EB minus or EG or generated induced EMF or induced EMF of, you can say anything. So I am calling here generated induced EMF EG minus armature resistance drop, or that is IA into RA minus brush contact drop. So this is the voltage equation of separately excited DC generator. So this is the separately excited DC generator. Now again we have self-excited DC generators. Coming to self-excited DC generator, that is classified into 3 types. You know already, we discussed it. That is series generator, shunt generator and compound generator. Now we will discuss shunt generator in case of the self-excited DC generator. In case of the self-excited DC generator, we are not using any autonomous course because of the induced EMF will be developed in the generator due to of the residual magnetism. So that's why we are not using any autonomous source here, means separate source we are not using. That's why this is called as a self-excited DC generator. In case of the self-excited DC generator, classified into 3 types. First one is the DC shunt generator. So in case of the DC shunt generator, according to the DC shunt generator or according to the construction of the DC machine, if armature winding and the field winding both are connected in parallel, then the type of generator I am calling as a DC shunt generator. You can observe this diagram. So this is the armature winding, this is the field winding. Okay. So this armature winding and the field winding both are connected in the parallel here. Okay. So then according to the Fleming's right hand rule, the direction of induced EMF will be upward direction here. So according to that principle of DC generator, the direction of the induced EMF will be depends on the Fleming's right hand rule. According to Fleming's right hand rule, the induced EMF direction will be upward. You can observe now. Now armature winding current is flowing like this, then divided at this node point according to what? KCL. Current entering into the node will be is equal to current leaving the node. So then current is here entering here, then load current is leaving here, and the field winding current is coming like this. Now this is connected to the what? Load here. That is connected to the load here. Now, so this load voltage is V I am taking here. Now you can observe here, this IA is equal to according to what? KCL. Current entering to the node will be is equal to current leaving the node. Which current is entering here? Only armature current is entering, and the load current and the shunt field winding current both are leaving here. So can I write now IA is equal to IL plus ISH. That is only I am writing. So this is IA is equal to IL plus ISH. Then can I write now ISH is equal to V by RSH. Why? Because of this shunt field winding is parallel with the armature winding. And as well as this armature winding is in parallel with the load voltage V. So means whatever the load voltage will be appearing across the load, same voltage will be there across this winding as well as this shunt field winding. Both, because these 3 are connected in the parallel, that's why voltage will be same. So then what I am getting here, voltage across the field winding is load voltage, that is V. Load voltage, that is V. So can I write now voltage we know and the field winding resistance is RSS. Then what is the current according to the Ohm's law? According to Ohm's law, what is my Ohm's law? According to the Ohm's law, sir, according to the Ohm's law, ISH is equal to V by RSH. V by RSH. Okay. So now can apply now here what? Again KVL, that is Kirchhoff voltage law. So according to the Kirchhoff voltage law, sum of the voltage in the loop will be is equal to 0. Again I am getting here what? Resistance drop, that is armature resistance drop I am getting, as well as the brush drops I am getting according to the construction of the DC machine. Now you can write now E is equal to V plus armature resistance drop is IARE plus brush contact drop is BCD. This brush contact drop is 1 volt per brush. So that is E is equal to V plus IA into RA plus BCD, where ISH is equal to shunt field current, RSH is equal to shunt field resistance. Shunt field resistance. Okay, and RA is equal to armature resistance, IA is equal to armature current. So this is the voltage equations for DC shunt generator in case of the self-excited DC generator. Now next DC series generator. In case of the self-excited DC generator, another type is DC series generator. In case of the DC series generator, you can observe here according to the connection, that is the field winding as well as the armature winding connection. According to the field winding and armature winding connection, this armature winding as well as the field winding both are connected in the series. So you can observe here in case of in this diagram, this series field winding resistance and this series field winding, and as well as this is the armature winding. Both are connected in the series or not? Both are connected in the series here. Now that's why this is called as a what? Series generator, DC series generator. According to the Fleming's right hand rule, the generator induced EMF is upward direction here. Okay, then I am getting the load connected to the load terminals. So now according to the series generator connection, armature winding and the series field winding and as well as the load both are connected in the series only. Now what you can write now? In case of the series, current will be same. So then what are the currents I am getting here? Armature current, that is armature resistance current, and as well as the field winding resistance, that is series field winding resistance current. Series field winding current, that is what? ISC. Series field winding current is ISC, and as well as what? Load current IL. So these three current are all are same. Why? Because this all are connected in the series. That's why IA is equal to ISC is equal to IL. IA is equal to ISC is equal to IL. Now you can write now voltage equation according to the KVL. So according to the KVL, Kirchhoff voltage law, sum of the voltage in the loop will be is equal to 0. Again, which drops I am getting here? Armature resistance drop I am getting, as well as the series field winding resistance drops also I am getting, and as well as the brush contact drops also I am getting. So means you are getting here 3 drops. You are getting 3 drops. That is, now what you can write now? E is equal to, the load voltage is V plus E is equal to V plus IA into RA plus ISC into RSC plus brush contact drop. Okay, but according to series generator, IA is equal to ISC is equal to IL. So can I write now V plus IA into RA? In place of ISC I am writing IA RSC plus BCD. Now IA is common I am taking, that is V plus IA into RA plus RSC plus brush contact drop. So then I am getting this is the equation. E is equal to V plus IA into RA plus RSC plus brush contact drop, where RSC is the series field winding resistance, ISC is the series field winding current, and I suffix A is the armature winding current. So this is the voltage equation for DC series generator. Okay. Now next, DC compound generator. So I already said DC compound generator is classified into again two types. That is, the first one is the long shunt generator as well as the short shunt generator. So what is mean by long shunt generator? Can observe the diagram here. So in case of the compound generator, we are getting two field windings. That is shunt field winding as well as the series field winding. Okay. Now in case of the long shunt generator, can observe here, armature winding and the series field winding both are connected in the series. Again that will be connected to the shunt field winding. Again that will be connected to the shunt field winding. Means in parallel. So you can observe here. This is the armature winding and the series field winding both are connected in the series. Again this will be connected to the parallel to the shunt field winding. So that's why this is called as a long shunt generator. This is called as a what? Long shunt generator. Again this will be connected to the what? Means load is connected in parallel with the armature winding in series with the series field winding. So what will happen here now? So voltage across the load will be equal to the voltage across the armature winding in series with the series field winding and voltage across the shunt field winding, because these all are connected in the parallel here. Means whatever the voltage across the load, same voltage will be there here also, that is V, and here also I am getting the same voltage, that is V. Okay. Now you can observe here now. What in the right now? Again armature current is flowing here IA according to the Fleming's right hand rule. Then this is the series field winding current ISC. Again current is dividing here, flowing through load IL current this direction and ISH current is this direction. So then you can observe ISH you can write now, like what you can write now? We know the voltage across the shunt field winding resistance is what? Voltage V. Okay. Now we know voltage and we know the resistance. According to the Ohm's law, ISH is equal to what you can write now? V by RSH. V by RSH. Now can I write now IA is equal to ISC. IA is equal to ISC. You can write now. This IA is equal to ISC. You can write, because this armature winding is connected in series with the series field winding. That's why IA is equal to ISC I am getting. Now what in the right now? IA is equal to IL plus ISH, or ISC is equal to IL plus ISH. You can write anything, but I am taking here main current is IA is equal to IL plus ISH. So then this is that one. This is that one. Next, what you need to write? Voltage equation. So how to write the voltage equation here? You can apply what? KVL. According to the Kirchhoff voltage law, that is sum of the voltage in the loop will be is equal to 0. So you can apply KVL here now. What I am getting now? EG, generator induced EMF, EG is equal to V plus armature resistance drop, that is what? IA into RA. That is IA into RA. And series field winding resistance drop, what that is? ISC into RSC. Plus brush contact drops. Brush contact drop, that is BCD. So this is the equations. What equations? Voltage and current equations for long shunt generator. Voltage and current equations for long shunt generator. So next is short shunt generator. So what is in the short shunt generator? Can observe here. This is also classification of compound generator only. That is short shunt compound generator here. So coming to short shunt compound generator, armature winding and the shunt field winding both are connected in the parallel, and that will be connected in series with the series field winding. So that type of generator I am calling as a what? Short shunt generator according to this connection. You can observe here in this connection. This is the armature winding and this is the shunt field winding resistance, shunt field winding. Both are connected in the parallel. Again, this will be connected in series with the series field winding resistance, series field winding. Okay, so that's why this is called as a what? Short shunt generator. Now this will be connected to the what? Load. That will be connected to the load. Now you can observe here, according to the Fleming's right hand rule, armature current here is then shunt field winding current ISH and the ISC and the IL. Here you can observe one thing, this load and the series field winding are connected in the series. So then what you will get now? ISC is equal to IL I am getting. ISC is equal to IL I am getting. So now can I write now IA is equal to ISH plus IL. According to what this is? KCL. Current enter into the node will be is equal to current leaving node. Which current is entering here? Armature current is entering and shunt field winding current is leaving and the series field winding current also leaving. So can I write now IA is equal to what? ISH plus IL. And also can I write now IA is equal to ISH plus ISC also, because ISC is equal to what? I suffix L. Okay, so that's why I am writing here current equation like this. So then what is the here? Then what you can write now? This is the then next what you can write now? Voltage equations. Now what you can write now? You can voltage equations is you can write now apply KVL, Kirchhoff voltage law. Kirchhoff, according to Kirchhoff voltage law, sum of the voltage in the loop will be is equal to 0. So what are the drops I am getting now? Armature resistance drop as well as what? Series field winding resistance drops as well as the brush contact drop I am getting. So now you can apply here. What you can apply here? VE is equal to, now E is equal to, what you can write now? According to the KVL, E is equal to V plus IA into RA plus ISC into RSC plus brush contact drop BCD. So this is the voltage and current equations for what? Short shunt compound generator. So this is the classifications of DC generators. According to the classification of DC generator, first one is separately excited DC generator and self-excited DC generator. Again, self-excited DC generators is classified into three types. That is the shunt generator and the series generator and the compound generator. Again, compound generator is classified into two types. That is a long shunt compound generator and that is the short shunt compound generator. For each type of generator, we wrote the current equations as well as the voltage equations. Okay. Now we will discuss one problem on this topic. Now, for example, it was given a shunt generator delivers 450 amperes at 230 volts and the resistance of the shunt field and armature are 50 ohms and 0.03 ohms respectively. Calculate the generated induced EMF. I was asking generator induced EMF. Okay. So what he was given? A DC shunt generator. So shunt is nothing but as a what? Armature winding and as well as what? Field winding, both are connected in the parallel. You can observe here. This armature winding, field winding, both are connected in the parallel. According to the Fleming's right hand rule, the current direction is like this. So now it was given what? A shunt generator delivers a 450 amperes. How much? 450 amperes at 230 volts. Means load voltage is equal to how much? 230 volts. Load current is equal to how much? 450 amperes. Now, next what it was given? Shunt field and armature resistances. It was given how much? 50 ohms and 0.03 ohms. So then 50 ohms shunt field winding resistance. Armature field winding resistance is 0.03 ohms. Okay. Now what you can write? What you need to find out here? Generated induced EMF. So in case of the generated induced EMF, first what you need to find out? Current through shunt field winding. So current through shunt field winding we need to find out in that what? That is IF is equal to this. We need to find out the voltage here. But we don't know the voltage here. But in case of the shunt generator, This all are connected in the parallel. That's why whatever the voltage across the load will be same across the shunt field winding resistance also. That is how much? 230 volts. So now what you can write now? According to the Ohm's law, I is equal to V by R. That is IF is equal to 230 divided by what is the resistance? 50. Then what I am getting now? 4.6 amperes I am getting. What is that is 4.6 amperes? Shunt field winding current. How much? 4.6 amperes. Then you can find out what? Armature current. So what is the armature current? You can apply what here again? KCL. Current entering to the node will be is equal to current leaving the node. That is, what is the current entering here? Armature current. Which currents are leaving here? Load current and as well as the field current, shunt field winding current. And what I can write now? IA is equal to IL plus IF according to the shunt generator voltage and current relations. Voltage and current relations. Now we know the IL value how much? It was given in the problem 450 amperes. And the field winding current we calculated how much? 4.6 amperes. Then I am substituting here 450 plus 4.6 amperes. Then I am getting the armature winding current is 454.6 amperes. 454.6 amperes. Then what he was asking? Calculated the generated EMF. So then what you need to find out here? Armature voltage drop is equal to what? Before that, IARE is equal to armature voltage drop is equal to armature current is equal to how much? 454.6. 454.6 into RA was given how much? 0.03. That is how much? 13.6 volts. And according to the shunt generator voltage equation, EG is equal to V plus IA into RA plus BCD. Or nothing but is what? Brush contact drop. What that is? Brush contact drop. But it was not given brush contact drop, then you can neglect, then you can write EG is equal to V plus IA into RA. So what is the V now? It was given how much? 230 volts. So plus I suffix A is equal to how much? 13.6 into RA is equal to how much? Armature resistance 0.03. So that is 230 plus, sorry, this is not 13.6. Armature current is 454.6. It is 454.6 into 0.03. Already we calculated how much? That is 13.6. That is 230 plus 13.6. So can observe. Now EG is equal to terminal voltage plus armature drop. That is EG is equal to V plus IA into RA. That is EMF generated in the armature is equal to EG is equal to 230 plus 13.6. How much? 243.6 volts. 243.6 volts. So like this we need to do the problems. Okay. So today topic is classification of DC generator is over. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.